is posted to our YouTube channel. For those of you who don't know, the Institute for a Sustainable Future is a environmental institute at Purdue University that is combined the former Purdue Climate Change Research Center and Center for the Environment last August. And so we continue now to promote sustainability research across disciplines at Purdue and beyond. I'd like to invite also now Jill Hoffman from the White River Alliance to welcome you. And then Bill Chris will also be in charge of moderating this event. Thank you very much, and I hope you all enjoy this informative presentation.
Great. Thanks, Lynn. I really appreciate the welcome and for running all the technical behind the scenes part of this, which can always be challenging. Hello, everybody. I'm Jill Hoffman, Executive Director for the White River Alliance. We are a regional nonprofit organization working on water issues in central Indiana in particular, as well as statewide. We're a pretty diverse group, so check us out if you have some time. I also wanted to welcome you to join us for another awesome event we have coming up, the Indiana Water Summit, which we have been hosting since 2018, and that this year will be August 10th and 11th. This forum is actually one of the ways that we continue to keep summit conversations alive year-round. We host these forums with our partners at universities in order to help get the really great work and research going on at universities out of the university and into our larger water community, whether that's professionals or the public. So we like to host these forums in advance of the summit and then afterwards, particularly around topics like this one that can be fairly complex and need a little bit more time. So hope to see you guys again in August, but in the meantime, we're really thrilled to honor the number of researchers and people working in our communities on these important issues. So with that, Bill, will you let us know who those awesome researchers and speakers are joining us today?
Thanks, Jill. Happy to be with you all. And to kick off the presentations, I'm going to ask you all to remain on mute throughout the forum so that we can avoid any background or other extraneous noise during the presentations. Over the course of today's forum, as you'll see, we'll move from science toward action. So the first couple of presentations are going to be presenting some important research, and then we're going to transition to some work going on in communities, and then also options at the individual and household level for building climate resilience. I'm going to introduce each of our 5 speakers when they begin instead of all at once. So let's start. I'm going to begin with our first presenter, who is Dr. Thomas Hertel. And Dr. Hertel is Distinguished Professor of Agricultural Economics at Purdue University, bachelor's degree in economics from University of North Carolina, master's in public and international affairs from Princeton, and a PhD in applied economics from Cornell. His most recent research has focused on food and environmental security and impacts of climate change and migration policies on global sustainability, trade, land use, and poverty. He's going to tell us about a research project he first established in 2017, so I won't describe that. He's going to, but I will mention that he's a fellow of the American Association for the Advancement of Science, was awarded the inaugural Purdue University Research and Scholarship Distinction Award for outstanding accomplishments in the social sciences or humanities. And if I read you the rest of his awards, I'd take up all of his time. So Tom Hertel, if you would, go ahead and share your screen and let's get underway.
Great. Thank you, Bill. Thanks for that kind introduction. And it's a great opportunity to meet this group. I've been asked to talk about GlassNet. So I'm going to do that in a variety of ways. I'll tell you a little about GlassNet, but then I want to illustrate this with 2 research narratives, one on climate impacts and one on mitigation, and the second one bears directly on water. So GlassNet is something that NSF is supporting. It's a long-term project aimed at building networks, a network of networks So here you have a picture on the right-hand side of the networks we're bringing together. GTAP is something I've been involved in for a long time, global economic analysis, but we've got quasi hydrologists, natural capital project ecologists, and many others, as you can see, and there are networks from across the world. We're focused on land and water resources. And so if you think about the UN Sustainable Development Goals, half of those are somehow tied to land and water resources. So the kinds of things you're worried about here in your alliance in Indiana are certainly relevant for many of the Sustainable Development Goals and across the world. Our theme behind GlassNet, our angle, is that we undertake global to local analysis. Our argument is that, as you would well appreciate, sustainability research has to be local because circumstances vary from one field to another, from one community to another, whether it's governance or water rights or precipitation. All of these things are very local, determining land and water use. So we have to start there, but the global forces driving sustainability stresses, those forces are global in nature. And so you need the global, you need the local, and then once you intervene, as I'll show you later on, this can feed back from the local to global. So that's our theme, and I'll illustrate this through 2 research efforts. We'll start with climate impacts, and while this doesn't bear on water in Indiana, it's a super important topic, and it's done in collaboration with the director of the Institute for Sustainable Future, Matt Huber, and I wanted to highlight that. Then we'll move into climate mitigation, climate change mitigation, and how that can yield water quality co-benefits. So first on the Matt Huber front, you see a picture of him down there with one of his collaborators, Jonathan Buzon. They've really pioneered the study of human heat stress. Human heat stress, as you all know, occurs when it's hot, but also when it's humid. You can't dissipate the heat. And hot, humid weather, working hard outdoors, this looks a lot like farming and construction in the tropics, and that will be a highlight of this short presentation here. This is work that Matt and Jonathan did, just summarizing over the broad spectrum of the high latitudes and the tropics at different levels of global warming, how many people may be limited in terms of labor capacity, their ability to work due to the conditions they're suffering under. Of course, agriculture is the hardest hit sector. That's where people are most exposed to the heat and humidity. And what we find in this work is that less labor capacity, people need to take rests more. If they work, they have severe health consequences. You need more workers. And where are they going to come from? They'll have to come from other activities. And what draws them in there? The fact that this crisis in agriculture reduces output and raises prices. So this is bad on a number of counts for society, especially for the poor who spend a lot of money on this. So we have estimated that this could have a big impact on the labor markets. When we look at it across the whole economy, so economy-wide labor losses, we have construction in there, but manufacturing, other things, and added up to the national economy, we see that this is most severe in South and Southeast Asia. Here you see Pakistan lighting up, for example, but also West Africa. When we convert that to GDP terms, economists like to put dollars on these things. It's really West Africa, and in particular Nigeria, that is the most affected, and this is just because of the composition of their labor force, their reliance on agriculture and construction activities, for example. So big losses in GDP there as a result of climate change-induced human heat stress. This translates through all of these mechanisms, and this is where GTAP comes in. It's a model which looks at the whole economy, looks at trade, because other countries are affected too, and they'll affect your imports and exports. Food prices change, wages change, and we translate that into changes in poverty headcount. So here we've worked closely with the World Bank, taken their entire survey the population for these countries in West Africa and done what they call a micro simulation to look at how those households are affected. And you can see that very significant impacts on poverty, particularly in Ghana, Nigeria. And you can see it depends on which part of the population you're talking about. On the right-hand side, these bubbles show how many poor people there are in these different strata of the population and how they're affected. So it's these non-agricultural households that are most severely affected. They're likely living in urban areas, don't benefit from the higher food prices, and have to, of course, pay much more for their food. So that's a bit of a lens into the human heat stress. Of course, this will affect us in Indiana as well. Although in agriculture, we have the benefit of air-conditioned cabs. Much of the agriculture is mechanized, so it'll be less severe here and less severe increases in that combination of heat stress and humidity. That's just a little teaser for that work that we've done jointly. So that's involved the network of climate change people and the network of economists and development people, bridging those networks. Now I want to talk about a project in GlassNet that links agronomists, agroecologists with economists, with hydrologists and ecologists to look at climate change, possible co-benefits of climate change mitigation in our part of the country. So just pulling back and talking about this from a big picture perspective, people now talk about the planetary boundaries. We think about climate change a lot, but actually, if you're thinking about exceedances of safe operating zones on the planet, in terms of the planetary environment, it's really other areas that are even more severely stressed right now than climate change, in particular genetic diversity being lost and phosphorus and nitrogen pollution of water. And this group is well familiar with that. And so we want to delve into that and the connection between efforts to address climate on the one hand and efforts to address water pollution on the other. So here we have a schematic. Many of you have seen this before, this kind of thing. We have the Mississippi Basin draining into the Gulf, and we have a very large share of the nutrients provided, delivered to the Gulf, coming in the form of nitrogen from corn and soybean, for example, also phosphorus. And that's led to the Gulf of Mexico dead zone that we hear a lot about, and that EPA has been trying to address for more than a decade. And it's been very difficult, really an intractable, seemingly intractable problem. We haven't been able to meet the targeted reduction, say a 45% reduction in deliveries, loads to the Gulf. So let's think about this from another perspective. This group has been working on things like wetlands, but we wanted also to explore this from this other perspective of climate mitigation and potential co-benefits there. So the GTAP framework is widely used to look at climate policy. And we've constructed a scenario whereby the climate policy is geared around the social cost of carbon. So there's some uncertainty in the social cost of carbon, but this indicates the price which individuals should be paying if they want to emit more carbon. So a way of internalizing that externality. And we've looked at 3 different levels of social cost of carbon: low, medium, high, and the European Union, for example, with their emissions trading system is more towards the high end here. US doesn't have this kind of policy in place, but it's a useful benchmark for us, we believe. Well, one of the big impacts of this, when we look at this whole thing across the US economy, affects trade, imports and exports, but it also affects prices and energy prices in particular. And what's most important for corn production is the change in ammonia price, which then translates into the change of nitrogen fertilizer, change in price of nitrogen fertilizer. So almost a doubling here of these ammonia prices, because natural gas is used both as a feedstock and an energy source for natural gas. So very closely tied to natural gas prices. So when we put this into this framework and we tie the GTAP model with a gridded high resolution model focused on corn soy production in the Midwest, we begin to see the impacts here. And they're shaded because the impacts vary across location. But you can see at the top, the higher carbon price coming from this envisage model, GTAP type model. Higher carbon price translates into a higher fertilizer price, and that translates into reduced crop output, and that's what you're seeing mapped across the top. So reductions in corn production across the Midwest, that translates into nitrogen fertilizer reduction. So that nitrogen fertilizer prices use falls a bit more, because not only does production, you have less corn area, but you're reducing your intensity of nitrogen applications. And then finally, we translate that through what's called the water balance model across the landscape and all the way down to the Gulf of Mexico. And we can see some reduction in the nitrate transport to the Gulf, not by any means the total we need, but it's significant. And we do compare that to wetlands as a policy, a fairly aggressive wetlands policy. And you can see here that the carbon price, there's a lot of uncertainty around all of this, and it depends on the social cost of carbon you're considering, which we're ranging across the bottom here. But if you look over to the right and you look at nitrate, either going to the groundwater or nitrate export to the Gulf, you can see a more significant impact through this channel by which we raise fertilizer prices than through the wetlands policy. And it is important to note that there are some potential, also some significant benefits from reduced export to groundwater of nitrates. This also reduces spillover effects. If we just did wetlands alone, that reduces production in some areas, reduces nitrogen use in some areas, but it lends an incentive for that to increase in other areas that are unaffected. So on the other hand, the carbon pricing affects all producers across the Corn Belt. So just want to summarize by saying a little more about the GlassNet activities in this slide, that it's this network of networks collaborating. I'll show you the website in a moment. We'd love to have you folks engaged in this. We have a special issue of Environmental Research Letters, an interdisciplinary journal coming out that emerged from a conference we held on campus a year ago. We're supporting early career scholar exchanges. So if you know early career scholars who are interested in this, they should visit our website and get in touch. And we have use cases focusing on particular regions of the world, such as I've looked at in this last one, to address key research challenges. And we do offer short courses. There'll be one next April, May at Purdue. So this is the GlassNet webpage. Glassnet.net will get you there if you want to find out more about it. So thanks, Bill, for the opportunity. And I'll stop sharing here so I can see some people.
Wonderful. Thank you so much, Tom. I appreciate it. Just a reminder to our attendees that we would love to have you post any questions using, when you move your cursor, you get those buttons that pop up across your screen, chat or Q&A, and we'll keep an eye on those. But I'm going to start by asking Tom a question. I know you had, you started this with a research project called GLASS, and then it became GlassNet, the network of networks that you began describing for us. And if I remember what I read about it correctly, Tom, you're sort of coming to a transition point as far as your the NSF funding for GlassNet. You've got this special issue out in Environmental Research Letters. Talk about next steps a little bit for us while we field a few other questions from our attendees. Where now that you've built this global network, where does it go from here?
No, that's a great question. We're thinking about it a lot, Bill. And of course, to get to this point, you mentioned GLASS. That goes back maybe more than 5 years, 6, 7 years. I see Keith on here. He was involved in that at the beginning. So it takes a long time to build this up, to build support. We've gotten a lot of external funding now, but where we're going in the future, we're halfway through, almost halfway through GlassNet. It's a 5 to 6 years of funding. So we still have some time to build this out, but we would like to follow something like this very successful GTAP institutional model where we have consortium members. There's a consortium, kind of like the John Purdue Club for athletics. You want to get close to the athletes, you join the consortium. So people, institutions contributing a modest amount on an annual basis to support these activities generally. That's been an effective way for GTAP, and we would like to do something like that here. Of course, we'll continue to go after research grants and whatnot, but if you want to support this kind of project in an ongoing way, you need some core staff. To have the core staff, you need to have core funding. So that's our vision. Yeah.
And just to sort of follow on that, and I realize that, you know, some of the folks attending today are researchers, others not. So this would be a question that will be of interest to some folks more than others. But you're a social scientist by background and training, as am I. And you find yourself in a field of research where you need a lot of interaction with people in the physical sciences. That probably doesn't happen to the extent it should. What's been your experience? Obstacles, opportunities, benefits?
That's another super question, Bill. One thing I've noticed is there's a real paucity of, so I'm an economist by training, a real paucity of social scientists leading these kinds of projects. Some may have heard of the NSF Infuse initiative, Food, Energy, Water System. That has wound down now. We're at the end of an Infuse grant in the same area. And when I was working with program managers on that, they were complaining that they didn't have enough proposals led by social scientists. So I think there's a real demand for that. Personally, I think there's a great, we have a couple of great examples of Purdue, of people who've led these projects. Linda Prokope is someone who comes to mind, coming from a social science perspective. They could be very effective because maybe they don't have the same pony in the race that others do. They're willing to pull these things together. But I found I think it's a good, it has worked well for GlassNet, and that to have this integrative economic framework, as you just saw illustrated, where people then plug in their expertise and speak to their own areas of science. So, but that is a great question. I think personally, I think there's a great opportunity for social scientists who would like to develop a leadership role.
Great. And we're about to turn in a few minutes to Indiana. But I want to ask you to talk about this global to local to global dynamic cycle that really sort of motivates this research. And when when we communicate with our colleagues out west, for example, in the Western US, there you seem to get a different kind of a cycle of aridification, really, of some global drivers, but then local actions that are contributing to things like the drying of soils, which is contributing. So, just talk about those kind of dynamics and how you see the local playing back to the global. You gave us a couple of examples from this, but here's a chance to maybe
Very good.
One more, talk about one more.
We've been working on the groundwater front, the groundwater sustainability front, using this framework, and there we find that more than half of the unsustainable groundwater withdrawals in the U.S. Right now are being driven by developments overseas. So whether it's income, population, productivity, and so on. So that's an area where groundwater sustainability is one that seems to be driven by global forces. And yet, if you looked at a groundwater sustainability policy across the US, which we have done, that's one of the papers in Environmental Research Letters, you see a lot of spillovers, so, and including overseas. So we've got these highly productive irrigated areas in the US. If you reduce those or take some of them out of production, as is happening in the Central Valley of California, you need a lot more land elsewhere to offset that. So land use rises, that's the local back to global effect. So I think, and we've also looked at this in the context of just land conversion in the US. A lot of the pressure on cropland, as people would well know in this part of the country, when there's a boom or a bust in crop markets overseas, it affects cropland here. Oh, there's a question about design of cities.
Yeah, I was
Great.
just gonna point to that. So thank you for
Yeah,
stating that. Go ahead.
great question. We haven't looked into that. I think we need some collaborators from the urban side to be able um, to speak to that question. It's really not one we've thought about. And there may be important implications there. Obviously, the broader climate agenda, big implications for the design of cities that make them less of a heat island, for example, also water use. But it's not my area of expertise. I'm sure there are people on here who could speak more to that.
I'm glad to have a question in chat. Encourage folks to use that. Let me ask you one more, Tom. The special issue in environmental research letters, I've seen it, but probably many haven't. I want to ask you sort of a two-part question. One, environmental research letters is one of those things that people won't all have access to because it's typically going to be something that you access through a university library subscription, or is it open access?
It is open access. That's the beautiful thing about the
right,
IOP journals.
That's an important thing to know. So when I may even ask you to put that last slide of yours up one more time, if you don't mind, because it's got the link.
Okay.
Because when people hear about a special issue of a research journal, if they're familiar with research journals and they're not affiliated with the university, they may think to themselves, oh, well, hell, I can't see the thing anyway. So, who cares? But this is an open access journal. People can get to this.
Bill, I will, sorry, I didn't have the link to the journal. As
that's right. You had the link to Glass.
I will put it in chat. I'll put it in chat. When we're done talking, I'll put it in chat.
Yeah, with a concluding minute here, whet people's appetite a little bit. Some of the articles, some of the papers that are in that special issue.
Yes, the theme there is global, local, global across a wide range of things. So there's a paper on cyber infrastructure and how that can contribute, a paper on the way climate scientists across a wide range of things think about this global, local, global question. There is a paper on biodiversity. It's a perspective piece on how to think about biodiversity in this context, because so much of the deforestation is driven by global forces. So across a wide range of things, water, a number of other topics. So I will put the link, or perhaps someone already has. Yeah, I'll put the link in there, and I'll respond to this remaining chat as well in the chat, Bill, because I don't want to take too much time.
Okay.
Yeah.
So you'll just add a response in chat to the question.
Actually,
yeah.
If you don't mind me responding, that's a very interesting question. Do you think state and local policymakers should be engaging on this issue, and how? Jill poses that. I think it's a super important question about the groundwater withdrawal. So I think that is one of our points. We would envision in some perfect future that people could go to this website and zoom in on their community and see what the predictions are for future stresses being driven. Because when you're planning for a community, you may not be thinking about what's happening elsewhere in the world. We did a little mock exercise on this with a group from central Wisconsin, the Central Sands being very sensitive, pollution and in that area. And they found the way they were thinking about the future wasn't really consistent with the way economic models were saying the future was going. So we were able to give them boundary conditions for their local planning. Here are some parameters. Here's where we think your community, the land use in your area will be going in the future. And that was pretty helpful. We need to revisit that and make it more widely available. But I love the question, Jill, and that's something we would like to address.
Fantastic. Tom, I think we're going to close on that note. Thanks for getting us off to such a wonderful start. And I'm going to shift gears a little bit now. So make sure I've got this, get the right thing up here. Okay, hoping that you can see this now. And so it's my pleasure to introduce our next presenter, Keith Cherkauer. And Dr. Keith Cherkauer is a professor of Agricultural and Biological Engineering at Purdue University. He is also, as you can see here, director of the Indiana Water Resources Research Center. Bachelor's degree in, so here we go from the social scientist to the physical scientist, the very interaction that Tom and I were talking about. Bachelor's degree in physics from Augustana College, master's in aerospace engineering and environment with a focus on environmental remote sensing from University of Colorado Boulder, and PhD in civil and environmental engineering from the University of Washington. Through his research, Professor Turkauer works to integrate field-based observations, one source of data, remote sensing, another source of data, and hydrology models to address questions and concerns related to environmental change and to further our understanding of land-atmosphere interactions and the hydrologic cycle. But I think he is particularly excited to be here to summarize the findings of a report he and others have been working on for quite a while, and that is the Indiana Climate Change Impacts Assessment for Water. So the water report is here, and Keith, thanks for doing this, and it's yours.
Okay. When you get a chance, pass me control so I can move my slides.
I think that I did, but let me go ahead and advance your next slide just to get you going here.
Okay. Yeah, it's been the Indiana Climate Change Impacts Assessment was a project that started at Purdue and spread statewide, kind of a 2017, 2018 timeframe. A lot of the reports came out 2018, 2019, papers rolling out in 2020, 2021. We were last supposed to go live with this report in December of 2019, and we had things come up, so we missed it. And then, of course, COVID happened. So it has been a long time coming, and we are hopefully, the report is essentially ready to go, and I don't think I have control. So I'm going to ask you to go to the next slide there, Bill. So as part of the water resources team, this is the list of all of our co-authors, their general affiliations. We have Purdue University, IUPUI, Indiana University, Notre Dame, and the USGS are all contributing to this. We also had a lot of other people whose names appear as acknowledgements in the report who provided technical reviews and support to make this happen. Next slide, Bill. Next slide. There we go. So yes, we're going to go into Indiana, but I wanted to start with an overview of, I can't do everything, but I can do a few things. Right? I wanted to do an overview of U.S. climate changes that have been observed over, say, the last 100 years. We can focus here on the Midwestern United States, and you can see over the last 100 years or so that the trend in general has been increasing temperatures. These are annual average temperatures. The next slide. There we go. Next slide is precipitation. So you can see also that the Midwest was relatively flat for the first half or so of the last century, and then has been increasing pretty dramatically in the second half of the last century, with much of the Midwest expected to be getting wetter in the future. And next slide. So getting into the results from the Indiana Water Resources Report, if we look at annual total precipitation for the entire state, that since 1895 through 2019, precipitation on average has been increasing about ½ an inch per decade, so increasing from just under 38 to just over 43 inches per year. You can see that by the 9 climate zones in the state. So the central part of Indiana has increased 6.6 inches, the northeast corner of the state 4.2 inches. The southern part of the state has gotten the largest increase on that, over 8 inches. Next slide. Also looking at observed stream flow in this case, so all of the USGS gauging stations that have data over the last 30 years, you can see that almost all of them have been experiencing increases. So this is kind of right in hand with changes in precipitation. So increasing precipitation generally leading to increases in stream flow. The dark blue circles indicate that they are statistically significant. Light blue circles indicate that there is an increasing trend, but not statistically significant. And you can see some pink circles in there where there is some decrease. Next slide.
Oops, sorry.
Just
Back.
one slide.
There we go.
There we go. This, of course, also goes along with the fact that we are seeing some increase in high flow events and even in some flooding events. And so this is the St. Joseph River that runs along the border between Indiana and Michigan. You can see the first half of about the last century is in blue, and the record from the second half is in red. And you can see a general increase, kind of average flow to average flow. So you can see that in the observed record that is coming up. So that's just a single location compared to the previous slide. All right, now we can go talk about groundwater. So this now, the circles here represent USGS groundwater monitoring stations. So there are fewer of these than the stream flow monitoring stations. Each of these is being, so again, we looked at groundwater stations that have a 30-year record and looked at depth of the water table below the surface. And so in this case, if the water surface or the water table is rising, it's in a blue color. If it has been falling over the last 30 years, then it is red. You can see that there's a great deal of mixture in it, with some very large decreases in parts of the state and a number of locations that are also increasing. A few things to note. This map does not, in fact, indicate which aquifer any of these wells are. So not all of these wells go to the same aquifer. The groundwater system is very complex, and we have fewer observations of it. But we can still see, right, that there's quite a mixture, but that there is kind of a general decrease in groundwater in the northern part of the state, and a bit of an increase in parts of the south. Much of the northern part of the state decrease is probably attributable to irrigation in and around Indy, is probably related to increased urbanization and industrial use. Next slide, please. Okay, and then this one is looking at, so talking about irrigation, right? We can see that irrigation in the state of Indiana from surface water sources is relatively flat, but irrigation from groundwater sources has been generally increasing, especially post, I think that's 2012 right there, especially post 2012 when we had the last drought, we had a lot of people install. So clearly there are changes in usage. Can you get me the next part of this? Right, and so not in the report that's being released today, but in the supporting paper that came out in 2021, we also talked a bit about future change in demand on a county by county basis through the state. Next slide. And then, right, okay. So looking at the future conditions for Indiana, so everything that we've talked about up to now has been based on observational records and data analysis. So now moving into the future, we're bringing in climate projection or climate change prediction models. And then also when we get into the hydrology, we're taking the information from that and pushing it through hydrology models to give us things like stream flow and evaporation, snowfall. So this slide comes out of the climate change report that came out in 2018. And it showed that in 2050, there is going to be a statewide increase on the order of 8% relative to 1971 to 2000. Next. Get through the animation. You can see that that is not evenly distributed through the year, that we are actually seeing bigger increases in the winter and spring in precipitation, with summer and fall either decreasing a little bit or being about the same. It's not real clear from the future climate simulations. They don't entirely agree on what summer fall precipitation will look like. Next slide. Right, so again, precipitation is increasing, but summer conditions in particular are getting warmer, which is projected then to lead to increases in evapotranspiration of 6 to 7% in the middle of the century, 5 to 10% by the end of the century. And if we can go to the next slide. All right, so what that results in, if we look at kind of the future changes to soil water availability, the areas that are brown are areas where during the growing season, there will be less soil. We project there will be less soil water on an annual average basis. So you can see certainly in the southern parts of the state, that is a bigger issue. The northern parts of the state don't suffer quite as much because of the increased precipitation and I guess the difference in the soil types. But in general, going forward, we are expecting by end of the growing season to have a lot more deficit in soil moisture availability. Next slide. If we look at the balance of rain versus snow, here is a map of right, the fraction of precipitation falling between November and March that fell as snow. So you can see in the northern part of the state, almost 50% of that precipitation in the winter is falling as snow, whereas in the southern part of the state, very, very close to 0%. Next animation. So for Lafayette in particular, it has been historically 25% of winter precipitation has fallen as snow. If we are looking out at the middle part of the next century, same location, only about 10 to 15% of the precipitation will be snow. So that's a comment. I mean, so it's an increase in precipitation, but also an increase in temperature. So we still get snow, but it occurs a little less often. Next slide. Days with snow on the ground for central Indiana is projected to decrease from about 60 days to about 36 days. Next slide. Looking specifically at water, so surface water runoff, we are looking at an annual change, so an increase of 10% on an annual average basis. Next slide. Again, as with precipitation, this is different by season. So winter and spring are seeing double-digit percentage increases. Summer and fall are seeing decreases. And so that's right. I said there wasn't necessarily a huge change in precipitation, but again, with the increase in evapotranspiration, even if we maintain similar or slightly decreasing summer precipitation, we are getting fewer events that are producing surface water runoff, and flows in rivers will be decreasing. Next slide goes to the end of the century. And so you can see that the winter and spring changes increase and the summer and fall changes continue to decrease. So we are expecting this to continue to get larger as we move into the future. Next slide. Sorry, this one's got another animation. There we go.
Oh, sorry.
Just the one animation.
There we go.
There we go. Subsurface drainage. Most of northern Indiana in particular relies on subsurface drainage. Increased precipitation in the winter and spring is already leading to farmers increasing the density of their subsurface drain flow or installing where it wasn't before, though there are not many places in northern Indiana that didn't have drainage before. And so we are looking at, by mid-century, an increase of about 27% of current discharge into regional rivers, and 50% by the late part of the century. So that means soils are going to be draining faster, more water getting to the stream. Some of that is that there is less, that the weather is not as cold, so it's not freezing. There's less snow, so more of the water is moving through the system earlier in the season. Next slide. And you can do the animation on that one. There we go. So high stream flow. So events, this is looking now not at surface runoff, but at stream flow itself, looking at that across the state, an increase in about of 12% in that 10% of highest flows, 15% by the end of century. So we're expecting increases in those high flows. Next slide. All right. The report also uses 3 different watersheds to look at different parts of the state. I'm only going to show you the White River here. But if we look at the left-hand panel here, the black line is showing you monthly stream flow for the White River near Indianapolis. The 2 blue lines are showing you what projected changes are for middle of the century, the 2050s, and end of century, the 2080s. And you can see, right, that we are getting increases in stream flow in the winter and spring, so between January and May. And then as we shift into June, July, all the way through September, October, November, that we actually are seeing decreases. And that is illustrated to the right-hand side, which is just the difference, right? So we are seeing drops in stream flow of up to 15% in the summer, and increases in stream flow, in some cases up to 45% in, oops, sorry, you can go to that slide, but in the winter and spring. Just a couple of summary slides here, looking at some other aspects of the things we looked at. Water quality, we are anticipating, right, again, I showed you that there are increased surface runoff events, that is likely to lead to both more sediment and nutrients in state waters, especially when we have very wet conditions in the spring and farmers try to fertilize, and then we get a large rainstorm event. You get more of those, more sediment, more nutrients into local streams. Increases in air temperature are also going to contribute to increases in water temperature. So with increased flow in the spring, but also decreased flow in the summer, the chances for E. coli outbreaks and harmful algal blooms are more likely to happen in the future. And then again, summer low flows can also lead to an increased concentration of pollutants, since there's less water in the stream, and yet nutrients, in particular E. coli, are still moving through the stream system. Next slide. As for droughts, we are talking about hotter and potentially drier summers. So those are projected, and there has been a lot of growth and discussion in the research community about flash droughts, which are fairly rapid onset drought events. Historically, droughts build up over months, and these flash droughts are kind of defined as something that kind of pops up in a week or two. It doesn't mean that there wasn't something contributing to it for longer, right, people don't notice it until it's suddenly there. Therefore, it's a flash drought. They tend to be relatively short-lived. We are projecting that we will see more of those kinds of events at the end of the growing season in Indiana. However, that increase in precipitation, especially the wetter winters and springs, should reduce the likelihood of severe multi-year drought events like the 1930s. If we continue to get wetter in the winter and spring, even if we're ending the year in a drought, the expectation is that there should be, that those reservoirs should fill up again before the start of the next growing season. Now, looking at this year in particular, I don't know that we got enough water in large parts of the state. We got back to normal, but we are already at abnormally dry for the year, and a lot of our rivers are low because they didn't really recover over the summer. So not saying that we can't have more droughts in the future, just that we expect them to be shorter and not as severe multi-year, or not appear as severe multi-year events like they have historically. All right, now we can go to my last slide.
All right, very good.
right? And so that's just an overview of the water report. That is the website where the water report should be. The water report is fully approved even by the USGS at this point. But I noticed as of this morning, it's still not on that website. It still says coming soon. I have an outstanding question. I don't, to the people who are supposed to be overseeing pushing it to the website. I have not gotten a response. But Lynn was suggesting at the start of this that 2 weeks was probably a reasonable estimate, that it should be online in the next 2 weeks.
So maybe people can bookmark that site and go back to it.
Right. The other reports are all there, just
Yeah.
the water report at this point.
Okay. Keith, thank you so much. We're going to go into a few questions here before we switch to our next presenter. One question that was posted in the chat while you were presenting was whether the anticipated increase in runoff also account for land use conversion from farmland to other uses, or is this just the climate driver?
So the historical data, that would have all been mixed together. There would have been climate and land use. When we did the projections for the future, we left land use alone. Since the simulations for this report were completed in 2018, 2019, I guess 2020, we were doing simulations in there. Since that time, there have been some additional studies that have come out that have looked at least not necessarily changes in land use, but change that I showed that change in future demand. And so there is a dissertation, I can't remember off the top of my head if the paper has come out, that explored what those projected changes and withdrawals will do for water supply in the Wabash River.
Right. But in terms of like land use conversion, impervious surfaces increasing, things like that, that we don't have forward projections.
We don't have, we have historic. There is a I'll go back on that. There is a 2010 paper where we did some of that. But it hasn't been done recently, right? And so that was projections of future land use made in like mid 2000s, but looking at like 2030, 2050. So that there is a paper on that I can go find.
And let me get this other question in here. We had someone who asked about the water quality issues and what can be done to mitigate this degradation of the state's water quality in the face of these likely changes, particularly groundwater, since rural residents are especially likely to be depending on that for their drinking water supply.
I mean, I think we ended up with some suggestions in the document. In particular, there's a great need to increase monitoring of our aquifers. So there was a question about groundwater and a question about water quality. So clearly we do need more conversations about monitoring. We continue to have conversations about withdrawals and water transfers within the state. We had one last month. Well, there's going to be a conversation tomorrow at the Indiana Water Resource Association. I think Jane was on. I think there's a League of Women Voters talk in a couple of weeks, right? So there's a lot of talk about water transfers and groundwater from that perspective. I think we didn't have a lot of people on this report to do a lot with the water quality, but I think if we're considering moving forward with another report or doing some additional work on this, I think we need to be looking at methods not only for like water reuse, recycling, and storage on the landscape, but also implementation of best management practices, bioswales, rain gardens, other things to kind of reduce the amount of water that's running off. It is difficult to do in northern Indiana if we saturate the whole northern part of the state, there's no place for the water to flow because there's no topography.
Right.
All
right, we're going to sneak in one last question for you, and then we'll transition to our next presenter. Because since we're doing future projections, Jill makes the point that gray infrastructure pipes we put in the ground now built for 50-year lifespans. What kind of margin of error or margin of change, more accurately, should we be planning for when we are sizing infrastructure? And then also, how do we think about this in terms of floodplain mapping and the kind of ordinances that we may need in order to protect people and property going forward?
I mean, I think that those are all excellent questions, not directly covered by this report, but I do think if we're right that the data set that came out of this report and continuing work on climate change impacts in the state should get directed onto some of these topics.
All right, Keith, thank you so much. I'm glad we got to get a glimpse of these important findings from the water report, and we'll all look forward to seeing the full thing pretty soon, right?
Very soon, I hope.
Okay, all right, great, thank you. We're gonna now let me introduce you to our next presenter, Shannon Zila, who is, as you can see on this slide, with the Natural Resources Conservation Service of the U.S. Department of Agriculture offices here in Indianapolis. Shannon Zila is the Indiana State Resource Conservationist for the NRCS. And with this role, he supervises a diverse team of technical experts who provide guidance to the Indiana NRCS field employees who work with farmers and implement Farm Bill programs. And we've asked Shannon to talk with us today about some of the programs that particularly attend to what, as you can see here, he's calling climate smart agriculture. Shannon is a graduate of Purdue University and the Ohio State University. He made a point of, when he shared his bio with me, he didn't know that I was a graduate of the Ohio University, and so that always stings. But despite that, we're really glad that he's here. Shannon, it's yours, and I'll be happy to advance your slides.
All right, thanks, Bill, and good afternoon, everybody. Pleasure to be here. Next slide, please. Yeah, today we're going to cover number one, making sure everyone understands who USDA NRCS is and what services we provide to our local farmers and other landowners here in Indiana and across the nation, and what we're promoting our farmers do to mitigate all the various impacts you've already heard of today of the future of our weather systems. So really, who we are a part of the United States Department of Agriculture, the Natural Resources Conservation Service. We have a lot of acronyms, so we are the NRCS, much easier to remember. But in simple terms, we help people help the land. It's about the most simple way we can say it. We are one of the very few federal agencies who have authority to work on private lands in a voluntary manner. And we help farmers and other landowners manage their soil, their water, their air, their plants, animals, energy, and then also that human aspect of what comes with land management at the private sector. Next slide, please. As you've already seen some data, projections and past data, again, we're looking to have warmer winters and drier summers. It's about as simple as that. And that has huge implications for farmers, whether it's bringing in unique and different pests, having less frozen soil. The impacts are huge. Next slide, please, Bill. And we talked, we are looking to have more water here in Indiana, but when is that water going to come? Projections are that we're going to have wetter winters and wetter springs and drier summers. So if we are shifting that water balance into our non-growing season, particularly, what does that mean for our natural resources and the farming community and crops and everything else? So we're here to work with farmers to help them prepare for these changes that we are seeing. Next, please. So USDA is investing heavily in what we're calling climate smart agriculture and forestry through primarily recently the Inflation Reduction Act funding. And you may have heard of that, and we'll kind of get into some more details of what that means for the nation and for Indiana. But the purpose of those funds are kind of threefold. Number one, improving soil carbon. And we'll talk a little bit why that's important to the farmer as well as society. Reducing nitrogen losses, primarily nitrous oxides, one of the most severe greenhouse gases. And in general, to reduce, capture, and sequester greenhouse gases. Again, so it's kind of a twofold approach with multiple benefits throughout, but number one, to stop the emissions of greenhouse gases from agricultural lands, as well as becoming more resilient by sequestering more of that carbon into our soil. Next slide, please. So the key practices in this renewed effort is, as we can imagine, planting vegetation will sequester carbon, will keep our soils protected, that sort of thing. No brainer there. But another key factor of this approach is to improve our soil health across the landscape, as well as manage our nitrogen better, as well as our grazing lands and our forest lands. So again, these are pretty straightforward, but we'll get in a little more detail about this concept of soil health and what that means for farmers, especially here in Indiana. So next slide, please. So what is soil health? And again, if you picked up many agricultural magazines or environmental magazines, or this is a new buzzword, if you will, of what is soil health. And it means a lot of different things to a lot of people. But here in Indiana, we look at it as a journey. It's not something you can just measure and say that you have good soil health. It's more of an action with the soil being alive and active. So we look at indicators. And we talk about these concepts with farmers because they're the ones managing our soils. And if they're the ones who can make a difference on how they manage it, we want them to understand. So first and foremost, as we want to be increasing our organic matter. And if a farm is currently a very productive soil at 3%, we want them to get on a journey to up that, have a goal of 4%, 5%, keep increasing that soil organic matter. Improving aggregate stability. This is what keeps our soils stable when we get those heavy rains and those heavy snows, keeping it on the field intact. Increasing water infiltration. Anywhere a raindrop hits on the surface of the earth, we want that water to get into the soil rather than running off and causing problems downstream. We want to be decreasing our soil erosion. We want to increase our water holding capacity. If we get water into our soil, we want that water to be held there so that it's available for the crops and the plants when we hit these dry periods of our weather cycle. As I mentioned, the healthy soil is biologically active. That biology is constantly cycling nutrients. If it's cycling nutrients within the soil, it's less likely to leave the land and get into our water system and cause problems. And again, it's all driven by our biology, which needs to be our soil biology, which needs to be very diverse and very active. Next slide, please. It's actually a very simple concept that we talk to farmers and other land managers about. And again, this is not only applicable to cropland. It's primarily on cropland because Indiana's a heavy cropland state, but it applies, the same concepts apply to pasture land, to forest land, to urban land, to construction sites. First and foremost, we need to minimize disturbance. Disturbance can come in the forms of tillage, that can come in the forms of compaction, whether that's from an animal hoof or a bulldozer scraping the soil. We want to maximize soil cover. That comes in the form of crop residues as well as living plants. During the growing season, we have living corn and soybeans protecting our soil from the extremes of the weather, whether that's excessive rains, excessive heat, but also not overlooking the winter periods. And as we've seen some data, if we are going to have fewer cold days in the winter and yet the same precipitation, that's going to come in the form of rains. My kids are more used to brown Christmases rather than white Christmases when I was a kid, because we're getting heavy rains when the soil is unprotected and not frozen. So we're getting a lot of runoff during those winter months. We want to maximize biodiversity. In our corn and soybean crop systems here in Indiana, that is not a very diverse system. So we're looking to add additional crops into that system, whether it be cash crops, so like a small grain, or perennial forages, or bridging that gap with cover crops, annual plants that we grow in the wintertime, fall, winter, and spring to protect that soil, feed that biology, and improve that biodiversity that then feeds that diverse soil biology. And then finally, maximize continuous living roots. Most of our activity within the soil happens beneath the surface. As I mentioned, that soil biology is fed by the roots, not only of our corn and soybean plants, but during that gap period after harvest. Make sure we have living roots through cover crops and other crops within the soil keep it protected and fed. Next slide, please. And again, when we talk to farmers, they really understand this concept of organic matter. A farm with high organic matter, or even a part of a field with higher organic matter, from soil testing, they know that's the more productive part of their field or their farm. And science is very clear that if we disturb that soil, we release carbon from the soil in the form of carbon dioxide. That is burning our organic matter. We can't afford to mine that organic matter out of our soil. Our soil scientists and other research has pretty much shown that since the mechanization of agriculture here in the Midwest, we've lost roughly 50% of our organic matters from our soil compared to our native vegetation. I would further go a little bit further that most of that likely happened within the last 50 to 60 years when we saw the advancement of machinery, genetics, chemicals. That's when most of that degradation has happened. So we have to reverse that trend. If we cannot be sustainable against these extreme weather events unless we put that carbon back into the soil and manage it according to those 4 soil health principles. Likewise, as we build organic matter in our soil, it contains these very nutrients that our crops need and the very elements that our crops need: carbon, nitrogen, phosphorus, water. Organic matter acts somewhat helps the soil behave more like a sponge. So when that water does get into the soil, it's held there and available to the crops as they continue to grow during these dry periods. Next slide, please. So again, a simple approach on cropland, many practices that you're probably familiar with. Again, minimizing disturbance. We've got to get farmers to reduce their tillage, get into a no-till, strip till system, not only on their soybeans, but in the corn and every subsequent crop. Do their best not to disturb that soil at all. We need diverse and strategic cover crops. We talked about cover crops. There's a whole host of them, but we need to be strategic about that so that it's compatible with the next crop, the previous crop, and doing the best for that soil. We need to adapt our nutrient management. We can't just apply nutrients like Grandpa used to. We need to be very precise and adaptive to it. And as these systems mature and the soil biology starts to function, farmers need to adapt the amount of nutrients they put on for their primary crop. And again, with these systems come different weed and pest pressures. We need to have a more robust integrated pest management system using precision technology. And then where we still have low producing parts of the farm, put those into vegetative buffers, perennial vegetation, take those lands out of production, quit putting inputs in there, invest those inputs and those monies and time back into the rest of the more productive parts of the field and make it for a complete system. Next slide, please. So we're very proud here in Indiana that we are a leader in cover crop implementation here with our farmers, which leads to soil health. It's been a huge effort from our entire partnership and you all out there helping farmers see the value of incorporating cover crops and more diverse crop rotations into their systems, and they're seeing the benefits not only of increasing organic matter, but reducing inputs, recycling those nutrients, and cleaning up our environment at the same time. Next slide, please. So I kind of give you a brief overview of climate and agriculture and what USDA is promoting to help farmers deal with these upcoming changes, or I should say current changes even. But just recently, Congress passed the Inflation Reduction Act. And so we're going to talk a little bit about what that means for the nation as well as Indiana. One good thing about the Inflation Reduction Act is it's bringing a ton of additional money to farmers to adopt these conservation practices, but it's not bringing any new programs to the table. So it's using our current programs that we've had since the 2018 Farm Bill. It's just increasing funding for those programs. So you can see here that we are some of our more common programs: the Environmental Quality Incentives Program, Conservation Stewardship Program, some of our easements with the Agriculture Conservation Easement Program. These are the IRA funds expected this year. We got a small amount of money this year across the nation and in Indiana, but especially look how they ramp up. And these are millions of dollars. And if you're not used to what a $1,750 million is, that's $1.75 billion. So that's a nice amount of money invested in agriculture to help them implement conservation practices. You can see in 2024, our flagship program, EQIP, right there, 1.75 billion. That's coming next year. Our next year is October 1. So that's right around the corner. 2025, 3 billion, 2026, 3.45 billion, and all down the line on the different programs. So we're expecting a huge flush of money to help farmers implement these practices. Next slide, please. So what practices we're talking about? Again, I mentioned the Environmental Quality Incentives Program. And to keep it simple, this is our Fix It program, where we have a natural resource issue on a farm or on the land. We can come in with this program and help fix it. Whether it's livestock in the stream, manure running out of a waste storage facility, compaction, erosion, you name it. We work with cropland and pasture on this program, forest land, whether it's invasive species or overstocked and slower growing trees, confined livestock. We do wildlife work here, as well as a whole host of national initiatives. Next slide, please. Our other popular program is the Conservation Stewardship Program. And we think of this program as our reward for past conservation. We have a lot of farmers who have done a lot of great conservation farming in the past. This is their reward. They get an annual payment for keeping what they've done on the ground, but also funds to improve and take their farm to the next level. So again, this program is focused on cropland, pasture land is kind of lumped into one, and then forestry is separate. Next slide, please. So what does this mean? Typically in a year, we receive about $47 million in these programs I've mentioned that we get into the hands of Indiana farmers. For example, I don't have 2023 numbers here, but it's roughly 47 million we got. We put that in farmers' contracts for them to implement those practices. These programs are extremely popular. Again, we get 47 million. That's quite a bit of money, but we have a backlog or an interest of over 50 million that we couldn't fund. So the demand for our conservation definitely exceeds the amount of money that we have, which is a great situation to be into, but it leaves a lot of farmers hanging and not able to implement those conservation practices. Next slide, please. So along comes IRA, Inflation Reduction Act. And these are the projections that we're expected to see here in Indiana, anticipated funds. You can see there in our flagship program, EQIP, we're expecting another 16.9 million next year. Again, that's October 1. CSP, another 6.7, and our easements, another 4 million. You can see as 2025, now we're at 29.3 million. 2026, 33.7. Next slide, please. You add those together. Again, this is on top of what we currently get normally in Indiana. So you add that 47.9 million plus 27.6 in IRA funding, and we've got a large chunk of money coming at us. Likewise, with in 2025, it's getting even more. We're more or less doubling our amount of money, and in 2026, we're looking at normally tripling our normal amount of money. So there's a lot of opportunity coming for farmers. We're really excited about it. We are staffing up because we are going to be expected to deliver all these extra funds to our clients. We are also working strongly with our partners, entering into agreements, getting our partners ready to get these monies into the farmers' hands. But it's not just about getting the money to them. They also need that quality technical assistance that when they do go to implement one of these practices, that we can ensure that they are successful. So they continue this on as a business decision. And with that, next slide, please.
Fantastic. Thank you so much, Shannon. Let me check the chat real quick to see if there's where do the funds or monies come from is the question. And I think you mentioned the Inflation Reduction Act, but do you want to say anything more about that?
Yeah, they come from Congress. Congress passes the law, and then they get appropriated, and then shoved down to the states, and we then put it in the hands of farmers to get the conservation on the ground.
Very good, thank you. We're going to move forward. Just a reminder to our attendees that we're going to keep all of our presenters and have a little more time for Q&A at the end of the presentations too, the last 10 minutes or so of our time together today. So let me move forward to our next presenter, who is soon to be Dr. Kara Salazar. Kara Salazar is the, as you can see here, assistant program leader in Purdue Extension, assistant program leader for community development. Also works as a liaison between the Illinois-Indiana Sea Grant program and Purdue Extension, because she also has an appointment in the Sea Grant program as their Sustainable Communities Extension specialist, and currently a PhD candidate in natural resources, social science. One more cheer for the social scientists at Purdue University. Kara, glad to have you. Thank you for doing this, and let me move you through your slides for you.
Great, thank you so much. I really appreciate being here, and it's an exciting effort to share in this webinar as well. So if you could go back to the previous screen, I want to put a shout out a little bit to some of the collaborators I have and show their names as well. But to give you a little bit of context too about who I am, what I do, and how I work with these different organizations and networks. My work focuses on environmental planning, community development, and public engagement. And I do that through Purdue Extension and working throughout Indiana to serve the communities. And also I work throughout the North Central region of the US, working with collaborators and other projects as needed too. And from the Illinois-Indiana Sea Grant side, our mission is to focus on Great Lakes and Great Lakes watersheds. So we work in the Southern Lake Michigan region quite extensively. I collaborate in that region as well as with other Great Lakes communities throughout the US as well. And you can see on this slide here, there are several partners that are listed. This particular project is one that I wanted to emphasize and share for this effort. It's fairly new. It's a good representation of how we engage with communities and working on a specific project. So this very much is tailored to looking at a community planning approach and how we're integrating that into improving green infrastructure and hazard mitigation practices and linking those into planning. This effort was funded through the Extension Disaster Education Network. This is an organization that does hazard mitigation and disaster education and research efforts throughout the US, working with the Extension Network. You could go to the next slide, please. Thanks. And with this project, we had a very interdisciplinary, multidisciplinary group come together to create a curriculum, training, and toolkit for communities to think through these community planning issues. We completed this over the last year and a half, so we're finishing it up now. And we will, what I'll do is I'll walk you through the co-production, the collaborative ways that we developed this work, how we implemented it in communities, and give you a couple of snapshots of the two communities that we did more extensive pilots with. One is in Indiana, so the city of LaPorte in Northwest Indiana, and then we also worked with Hancock County, Illinois. So I'll highlight those briefly as well. We go to the next screen. Thanks. We came together for this project based on the needs assessments and the work that our group was collectively seeing within our communities and our regions. That communities do need technical assistance and research and support for resilience and hazard mitigation efforts. And from the lens that we have from a community planning and engagement perspective, we wanted to bring those aspects and those lenses together to help communities make some decisions, think about how they could integrate into their planning and work within structures that they have as well, while also bringing some new education and resources to these efforts. Go forward, please. We had a three-pronged approach for designing and delivering this effort. First and foremost is community engagement from that community development standpoint. The groups that we're working with were identifying needs, motivations, and barriers for hazard mitigation to understand where they're coming from, as well as their perceptions of green infrastructure and what they've implemented and what they're working towards. We dove a little bit deeper into planning and policy aspects, in particular ordinance development. We were looking at targeting areas with high social vulnerability index values so that we could think about how we can make some of these practices more accessible as for their planning efforts. And we wrapped it up with some implementation support. Through our Purdue Extension Rainscaping Education Program, we implemented a workshop series for rain gardens, and we had a demonstration rain garden installed for each of these communities that we worked with. And what we're working on now too is developing the extension toolkit so that this information can be shared and utilized in several different places too. To start this effort, we did scoping around several different terms and resources to come to a consensus with our group, as well as to help communities that we're working with go through resources, understand the terms, and also think about some other ways that we should be working on these planning efforts. From the community resilience standpoint, one of the resources that we're using and looking at and frame some of the work that we do is through the National Institute of Standards and Technology, this community resilience planning guide, and some of the different processes that are used there and highlighted there. And also focusing very much on a collaborative planning with diverse involvement framework for undertaking this type of a planning effort. Go ahead. And also thinking through the hazard mitigation aspect, pulling, of course, from FEMA guidance and EPA guidance, in particular, this guide for communities and building community resilience with nature-based solutions. Go ahead to the next slide, please. Green infrastructure was of focus for integrating into multi-hazard mitigation planning and community resilience planning for this effort. So we conducted education sessions on different types of green infrastructure practices and had several that we were utilizing. Rain gardens and bioswales were a particular focus for implementation support in this project. And although we do mention and work on climate action planning in a broader sense, it was a little bit more of an indirect focus for this project, but we do mention and integrate aspects of climate adaptation and mitigation within the series. To dive into what we did and what the toolkit looks like with these community planning efforts, as community development professionals, we start with scoping and introductory meetings so that we can understand the roles and responsibilities between the groups that we're working with, understand the purpose of what the community wants to work on, how we can all work together, and go through the logistics that we need to have a successful program. We also introduced our model for the rainscaping education program and started scoping out locations for demonstration rain garden and other types of green infrastructure demonstrations at the conclusion of the program too. Okay. And to help us think about a diverse perspective of bringing community groups together and people to work on this collaborative effort, we use the community capitals framework, which has several different capitals that represent different lenses of the community. This is a really great way and approach to bring together a diverse group across many different factors. And we use this framework to coach the groups in working on the different planning meetings, bringing people together, and getting input from a broad spectrum. Once we started getting into the community meeting series, the first part of what we worked on were community hazard planning and green infrastructure mitigation opportunities. We had a discussion in small groups looking at community hazard identification. We had several different tools that I'm highlighting interspersed with these slides to help with that identification in the group discussion. And then we took a deeper dive a little bit into existing plans and ordinances to look at barriers and opportunities for integrating these different types of resilience efforts into their plans. Some examples of what we did, you can go ahead to the next slide, include different mapping exercises to look at hazard identification. Go ahead to the next slide. Community discussion worksheets, working in small groups with different question prompts and sharing among some diverse parties that were coming to the meetings. Okay. And the code and policy review for enhancing resilience. So we did a lot of background work to compile this type of poster. We did tabletop exercises where we had some excerpts of plans and ordinances. We had some strategic discussion around some barriers and opportunities and used this example of a poster to take notes to help with future planning. In the next series of meetings, we focus more specifically on green infrastructure mitigation strategies. We used some decision support tools and education pieces to talk about green infrastructure so that folks are on the same page and understanding the opportunities and benefits. We also worked through prioritization, locations, and next steps. One of the tools that we were using and building from is a GIS analysis and cost effectiveness analysis for green infrastructure placements. You can go to the next slide. We utilize that background information in our decision support system, Tipping Point Planner, to walk through communities for an education series of targeting practices and looking at reductions in runoff, nutrients, and average cost for installation and maintenance for these practices to help them further identify which practices could be most suitable for their communities. Go ahead. And with that conversation, we had mapping exercises again, looking at green infrastructure placement and location, and had several different types of groups that were attending these meetings, from the stormwater managers to city engineers and planners to residents working and living within these different areas too. Okay. The result of the meeting series and the feedback that was received through this effort was then compiled with our team assistants into a final report template that the community can then take and use for their different planning efforts. We do tailor it based on the type of plan or effort that the community is wanting to work on, so that they have then this piece to glean from and use. However, we are not doing the final plans or the final ordinance updates. It's up to the community to create those and implement them. Next slide, please. And as we transition from the community meeting series and the discussions and the reports, we moved into the support for implementation for green infrastructure. So we did run the Rainscaping Education Program. This is a 2-day workshop format where we provide training to plan, install, and manage fire retention projects, particularly rain gardens. We do provide education in other types of green infrastructure as well. But we get pretty in depth on rain garden siting, sizing, design, installation, and maintenance, and we do site tours, and the groups in that workshop then contribute to the demonstration rain garden construction. Go ahead. And so the 2 communities that we worked with, as I mentioned earlier, we had for the more in-depth highlights of these tools in this program, we're in Hancock County, Illinois, and LaPorte, Indiana. Hancock County is located here in this screenshot with the arrow. It's in a population of 18,000. There are important tourist destinations here. They have some significant issues with flooding and aging infrastructure. They utilize this series to support their multi-jurisdiction hazard mitigation plan updates. And as a result of this effort, they've included nature-based solutions for stormwater management on infill lots as a strategy, and they're adding nature-based solutions in their codes and ordinances for new development. Excuse me. They also installed a rain garden in a strategic location as part of this effort as well. Go ahead to the next screen. Thank you. In LaPorte, Indiana, in Northwest Indiana, this is a population of just over 22,000. They have several natural amenities within their municipality, including multiple lakes. They use this effort to update their stormwater management plan, including several different aspects of green infrastructure. They were also have been working on a redevelopment corridor, and they are integrating a lot of green infrastructure. And we helped them then install the rain garden that you see in the bottom screen there to redevelop. It's part of a redevelopment of a city park area that has been very underutilized and will be have several different types of green infrastructure demonstration efforts located here. It's highly visible and is connecting to a lot of different locations. So this effort was able to help them springboard into more community awareness and having some concerted efforts around updating resilience and green infrastructure projects. Go ahead to the next slide, please. And to wrap up, we're finishing the toolkit that has all of the agendas, the processes, the education resources that we used, as well as the facilitation techniques. We're putting those together into a Google site. We have 2 locations where we will host those. The Community Development Extension Library listed there is accessible to anyone who would like to go into that and look at the different types of curriculum and other resources extension professionals have created throughout the nation. And Eden also has a resource dashboard. We'll be putting the toolkit there as well, so that folks in that network can take and use these resources as they'd like, and to support their community planning efforts as well. And so thank you so much for having to meet me today. And I'm happy to follow up too on some of our other program efforts. We do a lot, and happy to share some of those things.
Sorry about that. I need to get back on the audio. So thank you so much, Kara. Very interesting projects. We have just a minute or two for questions. There are a couple in the chat. I'm going to get to them, but I want to ask you while I pull up those questions. When you do this work, which is obviously valuable to the communities as well as to the wider state and national scales, how do you initially respond to the questions that must come of, like, why are we doing this? Or maybe people even put it more skeptically, why do we have to do this? And are the people who show up for community meetings like this, how do you deal with the possibility that you're just preaching to the converted, like the people who come are the people who are already on your side, so to speak?
Absolutely. And that's something that we work with a lot across the different types of programs that I'm involved with. So framing is really important too. And one of the reasons why we chose a community planning approach with this type of effort is to integrate into existing plans and existing efforts, and looking at where there are barriers to make improvements, so that we can start where communities are and help improve and build on those assets. The other things that we encourage and work with communities on are how they can then take some of these small wins or other types of efforts or plans that they have, reinvest, get some funding, continue to build on those successes. So it's definitely a scaffold approach, and you're going to have a lot of diverse perspectives there. That's why we also bring together really diverse groups and individuals to talk about these things. And many times when we're holding these types of meetings, it's the first time some people have even worked together, even if they're in the same city and working together in the same place. So it is an opportunity to have some of those critical conversations and to think about some new and different ways to move forward as well.
And we have a question here about how communities plan for long-term maintenance. You're helping them plan for sort of what sounds like mostly new projects, but then things have to be kept up. How does that get integrated into the process?
Sure, all of those things are part of the planning process. And when we do our training, we have a lot of different, we have a whole section on that during our training as far as maintenance and keeping your program successful. So being able to site the location properly, having the proper engagement to have project acceptance, and then also having the long-term investment for maintenance and funding are all part of the sustainability aspects of these types of projects. So very much covered in all of the work that we do too.
Great, thank you so much. We're going to go to our fifth and last presenter here, and then after that presentation, we're going to have some kind of open Q&A for any of our presenters. So if you have questions, including questions that are now making you recall something that Tom Hertel said, or that Keith Chirkauer said, or that Shannon Zizula said, or Kara, we'll have some open Q&A time here in a few minutes. But let me introduce you to Haley Cowart while she gets her presentation slides up. Haley Cowart is the Education and Outreach Coordinator for the White River Alliance. She graduated from Butler University in 2020. So we're appropriately ecumenical here. I forgot to mention that Kara has 3 degrees from IU. So it's not all Purdue here today. And Haley graduated with major in environmental studies and minors in Spanish and organizational communications. Before she joined the White River Alliance, she worked for the City of Indianapolis, Indianapolis Office of Sustainability, helping them create educational content and expand public engagement with the Thrive Indianapolis plan. Today, she's going to talk to us about the Clear Choices Clean Water Program, organized by White River Alliance, but it's a national program, and the newest pledge in the Clear Choices Clean Water Program. Haley, it's yours.
Thanks, Bill. Just want to check, make sure you can see my screen okay.
Yep, everything's up and looking good.
Awesome. All right. Yeah. Before I get into our newest pledge, climate change, which we're hearing all about today, I'm going to give just some background on the Clear Choices Clean Water Program, which is ran under the White River Alliance organization. So as you can see here, this is our website, our homepage. Clear Choices Clean Water is a social marketing campaign. So we've heard a lot about today on how researchers and organizations and companies can make a difference with climate change, but we also want individuals to feel like they have some sort of say and some sort of voice in this. So that's what Clear Choices Clean Water is about. We've got 13 different topical campaigns, and a lot of these have to do with some of the topics we've heard about today. As you can see here, we've got some green infrastructure topics like we've heard from Kara. We've got soil health, we've got water quantity and quality. And sometimes it's as simple as, making sure you're properly disposing of your trash so you don't contribute to litter. And sometimes it can get a little bit more complicated when thinking about soil health and forest stewardship or maintaining your septic system. But these are Clear Choices Clean Water basically provides an entry point to all these diverse different topics that have to eventually do with water. So looking at how does the program work? First, users come across Clear Choices messaging either online or in person. As you can see here, you might see it on social media, whether that's through our accounts or through our partners' accounts. We've also got a newsletter that goes out, so you might catch some messaging there. Or you might see some of these physical materials at our partners' events. Next step, this will take you to the Clear Choices page where you can see all of these different topical campaigns and decide which one you want to get involved in. And then you take the pledge, and then after you've taken this pledge, you can share it on social media, you can share it with friends and family, and just decide which action you want to take. And within each of these pledges, there are a number of different actions because everybody's in a different situation, circumstance, lifestyle. It's not one size fits all. After you've taken that pledge, you'll be added to our impact map. So you can see you're not alone in that choice. This is a collective effort. You can see here, this is specifically highlighting all of the people that have taken our Native Plants and Pollinators pledge in Indiana. So this is nice to see your name up here with everybody else, see this effort that everybody is making together. It's not just you. This is, even though it's online, it's good to see other people working together. You can also see the total pollution reduction load as well. And we'll get into that a little bit as well. After you take the pledge, you can learn more about the campaign of your choice. We've got a ton of pages of resources and information such as what this topic has to do with water, what you can do. And then lastly, once you've taken these pledges, you'll also receive email reminders about this commitment just to check in and make sure that you are staying true to that commitment you made, and also to provide some support for that choice. So Clear Choices Clean Water has two important outreach goals. This first one is reaching pledge numbers and just trying to get people to learn about these topics and make that commitment. And then we're able to see that measurable behavior change. Secondly, we want to increase awareness at a broader scale. So getting these messages out there, all of these different topics that have to do with our waterways and eventually have to do with climate change because they're all connected. So back to climate change. This is our newest pledge. This went live this month. You can visit our website at indiana.clearchoicescleanwater.org and take this pledge. This topic can be big and scary, and it can feel helpless sometimes. And so this campaign is really great for helping people realize there are things that you can do at the individual level that add up and make a difference. So within each pledge, as I had mentioned, there are a bunch of different actions you can take. Not everybody has to make the same exact commitment. So for climate change specifically, we look at transportation, dietary changes, and household changes. These are three of the things that we've found through research that have the biggest impact on climate change. So starting out looking at transportation, you can make the commitment to change your commute to work, whether that's using public transportation, walking, biking, or you can also pledge to no longer idle your car or use the drive-through. Looking at dietary changes, we all know, I'm assuming we all have an idea of what the impact that our meat industry has on climate change. So you can choose to reduce your meat consumption, even if that is just by 1 meal per week, or if you want to spend most of your week as a vegetarian, or you can go 100% all the way. And that last set of actions are household changes. So whether that is utility adjustments with your machines and your light bulbs, or how you're using your materials, whether you're consuming a lot of plastic water bottles, fast fashion, making some of those changes. But you're not making these actions without knowing what they mean. Every single action that you commit to, you're learning what kind of effect that has. So for this first one, you can see that we've done the research and the calculations on what your commute means in terms of carbon dioxide emission. So when you enter that in, it calculates what kind of reduction you have. Same with reducing the amount of meat you eat each week. As well, we've got statistics in here about each of those household changes, so that when you're choosing which commitments you want to make, you're learning about what kind of effects those have. And then, as I had mentioned earlier, after you take that pledge, you can continue to learn more about that campaign of choice. So specifically for climate change, we talk about the basics of climate change, what it has to do with water. And, we heard a lot about that earlier from Dr. Cherkauer. So, looking at quality and quantity of water quality, the droughts and floods that climate change, how that impacts our water, weather, pollution, all of those things. So through Clear Choices Clean Water, we always take these actions back to how they impact our waterways. As you can see here, we also talk a little bit about what causes climate change. And then at the end, what are the small choices that you can make that eventually make a big impact? Here's just a couple of screenshots from our educational pages. Again, if you visit the website, you can see all of the content in here. And if you have any questions on any of this content or information, there's a ton of links within it that you can expand on. Each pledge does include a climate change, or it includes its own quiz with just a few questions that cover some of the content that was in those educational pages. And this also just helps us track user engagement and just to see the effectiveness of the messages we're putting out. As well, each pledge has a ton of resources included. We've done a lot of research and studies on the content that's within these pledges, and we want to make sure that our users have access to these as well. Here's a few that we have within our climate change pledge. And then on our website, we also have a large resource database, which is really neat because you can, any topic you're looking for, whether that's learning how to build a rain garden, learning what it means to adopt a stream and host a stream cleanup, you can visit this resource database and filter based on the pledge you're interested in, as well as the file type. We have a ton of kids materials in here, which is really helpful. Some of these topics can be pretty big and complex, and we've got a lot of videos, interactive websites, activities, and things that kind of break these down on a more simple level for kids to understand as well. And all of that is online, but we have a lot of physical materials as well. Here's a couple of versions with our climate change designs on them. And these are really great for just different events like farmers markets or booths, conferences, in parks and cities and towns, lobbies and offices. So we try to get these physical materials out, and all of our partners have access to these as well. So we've got a lot of different trusted voices sharing these materials so that people are hearing these messages over and over again, not just from us, but from people that they rely on and they trust to learn about these environmental topics. And as you can see here, these are all functional materials that are also educating people about these topics as well. And then, as I mentioned, we do have partners, and our partners have access to these materials, and they can customize them by adding their logo. So it's basically, you know, your own program, your own content and materials that you can have at your events to share the messages that you want to get out to your communities. And then our partners also receive a number of other deliverables, and this includes the pledges that have been taken in their region, as well as the pollution reduction load numbers. And then all of our partners also receive social media content to help get these messages out. So every single month we're highlighting a certain pledge. So for example, this month we are highlighting the Adopt a Strain pledge, and we get anywhere from 4 to 7 different pods of social media posts with content for them to share these messages. So it's a simple plug and chug. But I really just want to reiterate the importance of all of these different groups kind of sharing these messages that all bring us back to our waterways and thinking about climate change today. Again, it can be a scary topic, but there are simple changes that people can make at home, that they can make in their lawns and in their community, and together it really adds up. So that is all I have for the Clear Choices Clean Water program. We've got our homepage and that QR code over to the left. And if you want to take a climate change pledge, we've got that on the right, or any other pledges as well is on our homepage. And if you're interested in any partnership opportunities, you can email me with my email below.
Great, thank you so much. Haley, I'm going to ask you to leave that screen up for just another minute.
Okay, sure.
Just in case people want to catch snap either of those QR codes. And then we'll also be taking any questions for you. You said that this is the 13th pledge. From what you know about the program, Haley, since you've been working with it, which have been the pledges that people have really gravitated to? Any in particular?
Yeah, I'd say 2 of probably the most popular ones are our lawn fertilizer pledge.
Mhm.
And I think people seem to be, really surprised what kind of impacts fertilizer can have on our waterways when you see all of the algae and low water quality in waterways that are next to golf courses or neighborhoods with the real manicured green lawns. I think the numbers that we provide kind of surprises people. So there's a lot of information about how to check if your soil even needs fertilizer, what type of fertilizer you can use, alternatives to a green lawn. So I'd say that pledge is definitely one of them. And the other one is definitely our native plants and pollinators pledge. People love flowers, people love to plant them. And I think, people really want to know what is the best thing that they can put in their lawn that positively impacts our waterways? What can they do to protect pollinators as more and more people are realizing the positive impact that they have on our food systems? So yeah, I'd say those 2 are definitely 2 of our more popular pledges.
And both connected with soil health, one of our
Right.
earlier topics today. Jill has helpfully put the Clear Choices Clean Water web link in the chat too. So for anybody who wants to click through to that, bookmark it to go back to later, that's available there. So Haley, let's go ahead and take that screen down so we can see all our wonderful attendees again. Hi, everybody. We're going to open up now for questions. We've got just about 10 minutes remaining in our allotted time. And so there were some questions that have already gotten answered in the chat. I want to particularly thank Alan Hamlet, who fielded a few while Keith was presenting and right after Keith's presentation. So much appreciated there, Alan. And we've got one in the Q&A box here. Haley, is White River Alliance working to get corporate and industrial groups to make pledges since they could have a greater impact than individuals. So, Haley, you want to take that one?
Yeah, we do a lot of partnership work with corporate and industrial programs. So, whether that's them supporting some of the messages we get out through other projects under the White River Alliance. It is an individual campaign, so the pledge itself is definitely more for an individual person, but we do a lot of partnership work with larger groups to help share these messages as well that, they share within their organization so that it trickles down as well.
And thank you, Haley. I'm going to toss back a question. I'm going to go back to Keith and then move forward because this will also become, oddly enough, a question for Shannon and Kara as well. But Keith, I want to start with you because you've got this report and it has these amazing and intriguing findings. Some of which are sort of intertwined, well, all of which are intertwined with each other. And how do we try to avoid cherry picking? Like, I mean, in other words, people could look at this report and say, oh, it's getting wetter. So, we don't have to worry about things like soil moisture, or we don't have to worry about things like drought. I mean, that's a Western United States problem, or that's a whatever, and so simultaneously you have, projections of soil moisture diminished in the summer and fall, and yet, wetter precip and higher stream flow and all that. How do you sort of untangle that for folks? And then that'll lead me to a couple other questions.
How do I untangle? I guess I'm not sure that I untangle. I mean, how do we stop people from cherry picking is we need to be presenting things more holistically when we can.
Mm-hmm.
Anybody can go in and pull a specific number. I think I've already been doing that from the Indiana Ag paper or a link that's been posted where I've pulled out a couple of numbers. I think it's mostly about maintaining a conversation and making sure that these kinds of documents get out in front of people, and especially other groups that are doing work in this space.
Mm-hmm.
Right, there is no reason that the climate change report can't feed into what we're doing with soil health or water pledges or other things.
That makes great sense, and the soil moisture aspect of it leads me to another question, and I'm going to ask you to respond to this and then see if Shannon has some thoughts on this too. We've had historically in Indiana, and you can correct me if I overstate this, which I may, we've had a kind of an emphasis on drainage, on getting water off the land. We're looking at a recent past and a future where we're getting more water, but in larger storms and in a half of the year, while the other half of the year, if anything, is staying the same or getting drier, and even soil moisture deficits in substantial parts of the state. Is it time for Indiana to pivot from just thinking about drainage to thinking about storage? And in particular, things like groundwater. I'm not talking about necessarily, large reservoirs. That's a difficult thing to get done. But should we be starting to think about our groundwater resources, not just as supplies, but as places to put water when we have a lot of it?
I mean, I think Indiana needs to be thinking about how to deal with short-term deficit in water storage. I think Alan just posted again, right, that it's getting wetter and drier.
Right.
Right. I would agree that Indiana is not going to be looking at large surface water reservoirs. I'm not convinced that Indiana is going to be looking at aquifer recharge as a major component of what they're doing in the future. And we have very complex aquifers, and we don't, in fact, we don't make use of our aquifers to the degree that other parts of the US do. So they're still largely untapped. But I do think that there is a need to think more about management of water in the landscape. So controlled drainage, so putting boards into drainage systems so that they only drain when you need to do field operations, to plant and to harvest and to hold water in the soil, looking at wetlands and depressional areas in the landscape, excavating ponds, capturing drainage water and applying it later in the season. I think there's been some people starting to look at storing water in drainage canals and other things. So I think there's a lot of opportunity for kind of that local landscape storage that we aren't doing much with. Improvement of soil gets at some of that. And I see Alan has turned his camera on, so he may have some other things to say about this,
Sure.
right? But we're not going to be putting, Lake Lafayette is on the book somewhere, but nobody's going to put it in.
Okay. So let me do this, because I want to make sure we don't lose all of our time for other questions. But Alan, quick, and then Shannon, how do you talk to about this at the farm scale of water being on the one hand something you need to try to control from a flooding standpoint, on the other hand that's water you might need at some point. And then Kara, similarly from a community standpoint, how do you think about this in terms of both flood mitigation, flood risk mitigation, but also how do you think about that water as something you might need? So if I could, real quick, Alan, Shannon, Kara.
I'd just like to reiterate what Keith said about groundwater storage. I think, this has many benefits. If we can store the water underground, we eliminate evaporative losses. We don't have to lose farmland because the storage is underground. So there's a lot of reasons to do that, and it's just not really been explored that much, and connects with so many different things like soil health and infiltration capacity. The climate change projections also show increasing recharge in general. And so that suggests that approach would be sustainable as well. Right.
So some of it might occur naturally, but conceivably could also be enhanced.
Exactly. I think if we more intentionally manage it, that's one approach.
I see. Okay. Shannon, thoughts about this at the farm scale, and Kara, thoughts about this at the community scale?
Yeah, you mentioned tile drainage, and in most of Indiana, especially the northern part of the state, tile drainage is essential for crop production. But the key to that is, you only want to remove the excess water when you are either planting or harvesting. So again, you talk about water retention, whether that's above the ground or below the ground, you're plugging tiles when the water is not needed to be drained off. But also it's that whole soil health concept. If water is not getting into the soil, it's running off. And so it's not even available to recharge your groundwaters. So again, it's that systems approach. So, even our top soil health farmers have drainage, tile drainage, but they've managed their soil to retain that. Tile drainage won't remove the plant available moisture. It's only going to remove the excess moisture. But again, you've got to manage it as a system. It's all part of that whole system as well. It's education, making sure everyone understands that, because farmers wish they had that 3-inch spring rain in July. If it's gone, it's gone.
Exactly. All right. Cool. Thanks, Shannon. Kara?
To add to that, I echo the education aspect, thinking from things from a holistic standpoint, but also thinking about where we can integrate. This shouldn't be a topic that is looked at from a very narrow lens, or when we need to, being able to integrate into planning efforts and having those conversations, having these planning tools available for communities to use when they're updating their plans and they have resources to go to, is what we all need to be thinking about, so that we can cross over more and have more of these collaborative conversations.
I want to thank White River Alliance. I want to thank Purdue Institute for Sustainable Future, 5 wonderful presenters, and a great group of attendees with excellent questions. As time runs out on us for this afternoon, one quick plug. We'll talk about these things some more in August 10th and 11th. This will be an in-person event, in case you like to see actual human beings in 3 dimensions. And this will be at the Athenaeum, downtown Indianapolis. Please save the date, and we will have registration and early bird rates up and running this week. So look forward to seeing as many of you as can make the time and join us for the Indiana Water Summit, the 6th of them. Thank you once again, everybody. Enjoy the rest of the day. It's great to be with you.